Video we looked at ionization energy, and in this video we want to talk about atomic radius really quickly. So remember, atomic radius, our arrow comes back to the left and down. So as we come from, family 18 back to family number 1, the atomic radius gets larger. And the reason is you have a smaller effective nuclear charge over here. Family 1's a positive 1 effective nuclear charge. Family 2 is positive 2. So as we come back to the left, there's a lower effective nuclear charge, meaning the nucleus doesn't have as much of an effect on that valence electron, so it's not going to pull it in as much. So we're just going to compare sodium to magnesium. So sodium's in family 1, and here's magnesium in family 2 right next to it. Just one proton, one electron away from each other. And we notice that magnesium has 145, that's picometers for atomic radius, and 190 for sodium. So that trend that we said as we come back to the left is larger. We can definitely see that as we move back to family 1 where there's a less effective nuclear charge, you're going to be able to take up more space. Well, that's to the left. Let's go down. So instead of magnesium, let's try rubidium. So rubidium, as we go down, you can see that our atomic radius is up to 265 picometer. The reason it gets larger as we go down is because you have more electrons, you have more energy levels, you have larger orbitals, you have your S, your P, your D, and F, you have all this stuff going on, that they're just going to take up more space. So it should make sense to you that as we go down, they get bigger. We can look at cesium and notice that 298, it's even bigger than what we had for rubidium. Now this simulation doesn't let me do francium, but we've talked about this. Francium is the most reactive metal because it's got the largest atomic radius, and it also has the lowest ionization energy and the lowest electronegativity. So it's going to let you take that electron away from it. Now, the next thing that I want to show you is our ionic radius, just for a second, and then the next video I'll show it a little bit more too. So we've got cesium here as a plain old atom, and we have cesium here that I'm going to turn into an ion. So if he gives away that one valence electron, notice my ionic radius is smaller. So I'll do it again. I'll make it back. So we had 298 for the atomic radius, and as soon as you give it away, your ionic radius is smaller. Remember, the more we give away, the smaller it's going to become. So I can refresh these guys, and let's do sodium and magnesium. So sodium gives away 1. Okay, so it goes down to 102. Magnesium, remember, gives away 2. As he gives away 2, it goes down to 72. So remember that little trick we said. The more you put back, the more you give away, the smaller you're going to be. The next video, I'm going to show you the electronegativity and the anions of taking the electrons in. This simulation doesn't let me pull them in, so the next video will let me show you how to do that.